On page 102, example 5 asks that we graph the first 5 terms of each sequence. What's the domain for each sequence? What's the range? How would you classify each sequence? So here we have the function rule that we're going to be using for this sequence. So we want to graph the first 5 terms. We're going to start off with 1. So we want the first term, the second, the third, the fourth, and the fifth. So we're going to put 1 into our rule and get 2 minus 1 is going to be, so 2 times 1 minus 5 is going to be equal to negative 3. So we're going to plot the point 1 and over 1 down 3. So 2, when I plug it in, I get 2 times 2 is 4 minus 5 is negative 1. So I'm going to get the point 2, negative 1. So I'm going to plot over 2 down 1. When I put in a 3, I get 2 times 3 is 6 minus 5. So 6 minus 5 is 1. So I have the ordered pair 3, 1. So I'm going to graph 3, positive 1. When I put a 4 in right here, 2 times 4 is 8. 8 minus 5 is 3. So I get the point 4, 3. So the ordered pair 4, 1, 2, positive 3. And then 5, 2 times 5 is 10, and 10 minus 5 is 5. So we get the ordered pair 5, 5. So I'm going to plot 5, 1, 2, 3, 4, 5. The domain, you can see it's discrete. So our domain is going to be all values of n such that n is equal to 1, 2, 3, 4, and 5. The range is a of n, which is going to be equal to negative 3, negative 1, 1, 3, and 5. Classifications, well, I just mentioned there are discrete separate points, so it's discrete. It appears to be a straight line, so we're going to say that it's a linear function. And you see it has that common difference. When I do these, I have negative 3, negative 1, so I'm adding 2, add 2, add 2, add 2. So my terms, to get from one term to the next, I always add 2. So this is arithmetic as well. Whoops. So let me move that up so you can see everything. All right, so then let's go to B. So for B, I have the function rule, a of n is equal to n to the second power minus 4n. So again, I want the first 5 terms, so 1, 2, 3, 4, and 5. I'm going to then figure out what my each term is by plugging 1 into the rule. So I'm going to have 1 squared minus 4, so that's 1 minus 4 is equal to negative 3. So I have the ordered pair 1, negative 3 to plot. Started the same as the last one. I'm going to put a 2 in, so I'm going to get 2 squared minus 4 times 2 is 8. So I'm going to get 4 minus 8 is equal to negative 4. So I have the ordered pair 2, negative 4. So over 2, 1, 2, 3, 4. 3 squared minus, and then 4 times 3 is 12. So I get 9 minus 12 is equal to negative 3. So I have the ordered pair 3, negative 3. So write 3 down 3. 4 is going to give me 4 squared minus 4 times 4 is 16. So I get 16 minus 16 is 0. So 4, 0. So 4, 0 here. And then 5 squared minus 4 times 5 is 20. So 25 minus 20 is 5. So I'm going to get the point 5, 5. So 5, 1, 2, 3, 4, 5. The domain, again, is going to be n such that n is equal to 1, 2, 3, 4, and 5. The range, a of n, is going to be equal to negative 3, negative 4. I don't need to write negative 3 again. 0, and 5. Classification, again, it's discrete. Those are separate ordered pairs, separate points. It is not linear, is it? And it is, let's check, is it arithmetic? Here is a -1 and then a +1. So it's also not arithmetic. So the only thing we could say about it is discrete. It's not arithmetic, and it's not linear.